Right.
Awesomeness.
Excellent. So as Matthias said, my name is Kalle. And I think, well, most of you that usually attend CT probably heard me a few times already. I usually come here to do some stupid short talks about technical mumbo jumbo. Same thing today. I'm going to be talking about technical mumbo jumbo. To keep my tradition, I'm going to try to do some demos as well. And we shall see what happens with them. Anyway, I work for a company. Like most companies, this company has a website. This is what it used to look like in the late 90s. It does not look like this anymore, partly due to the fact that we hired this guy, Thomas. Thomas is our head of marketing, and as the head of marketing, he wanted to make this website a bit fancier than what you just saw. So he said, I want to use WordPress. Yeah, this is our reaction. It's like, no, really? But it was like, oh, come on, guys, I really need it. And I mean, you can't say no to a face like this. So like, fine, you can have your WordPress, but I mean, we're gonna take your shitty WordPress installation and we're gonna like put it somewhere remote, like isolate it, keep it safe from like the rest of the world, or rather keep us safe from this WordPress installation so that we don't have anything to do with it. And so put it out on the town somewhere. And so this is fine, of course, because it doesn't really affect our other systems. It's just a shitty front page with like irrelevant content. But still, it is like the sort of publicly facing website, and it's a bit sad when like this happens to your publicly facing website, which it does like from time to time, especially if you're running WordPress. I mean, this is what the like some airport in Sweden used to look like. This, as you can see, is the Dublin Rape Crisis Center. Probably not what they want to expose. So how do you make this not happen if you run WordPress? Well, answer is simple. You just take your site and export it to static HTML. And you put your static HTML on a static HTML server and like see if anyone can hack that. Of course, if you have a 0-day in Apache, you could do it, but then you could probably do a lot worse as well. So this is all fine and dandy. We have like our web page and a static HTML server, and everything's good. Sure, there are a few issues. I mean, like DOM-based cross-site scriptings or open redirects, possibly DOM-based, but not really relevant, like from an actual security perspective. However, of course, Thomas really wanted to have a form mail function because it's for some reason really important that people visiting the website can fill out a form and say, contact me, and some mail gets sent to some persons without the visitor having to open their mail client. And of course, this means that you need to have some sort of dynamic function. Something needs to receive a simple HTTP request and parse it and send out a mail. And of course, there are a bunch of scripts that does this, like formailpl, if you're familiar with this. And this is like sort of sums up all those kind of scripts. They're really shitty, terrible security, and they will like mess your stuff up. So I figured like, well, it's a really simple piece of code, so like just hack it together. So figured like it should be like a few lines of code and can write it in pretty much any language. So I sent out a mail to my colleagues saying like, anyone have any preferences as to which language we should use or platform that we should use? And of course, we had some discussions, but it didn't really end up in anything constructive, so we didn't really come to any conclusions. So I sent out another mail as a joke, saying like, okay, so since we can't really agree, let's do it this way. We take the form data, we encrypt it in HTML, on the HTML form using a JavaScript PGP implementation, so public key encryption. And then we take the result and we chop it up into small pieces, and then we take all these small pieces and we put them into host names. And these host names, we point them to various other domains. And now here comes the fun part with working for a company that does IDS monitoring. So we have a bunch of sensors at our customers' networks which monitor security incidents in the network traffic. So what you could do is to actually use their domains. So long as you monitor the traffic to the authoritative web server for the domain name, then you could actually do like this. So the person submitting the form will actually explode the form out into the world to the various DNS servers that are authoritative for those various domains, where we have the sniffers, which just reassembles the packets from outer world, throw it back into our security operations center, where we can reassemble them and like throw away the mail or read it. Sure, it's like, well, it's meant as a joke, of course, but it would be theoretically possible, and we could do it like without actually even having a server. But of course, then I got a mail back from this guy a few days later. He's sitting right there, Christer Hedfors. And he sent me the mail saying, OK, so I built the backend. Now you have to build the front end. So, of course, if we're going to push it that far, well, let's do it. After pushing it back and forth a few times, this is what we ended up with. So we take the form data and chop it up into pieces, and then we generate some sort of packet ID just to identify the message. And we have the frag index, which is like, which packet is this for this particular form post, how many packets are there, how much data do we have in it, and the actual data, which is around 90 bytes. And then we use this really awesome library called Knuckle. I actually use Tweet Knuckle for JavaScript, but it's a really great public key cryptography library that does this with the elliptic curve cryptography. And it's really nice for a lot of different reasons, and it really works actually pretty much off the shelf if you do it correctly. You can interact with Python, JavaScript, and what have you. So after encryption, we add a nonce to make sure that every packet is unique, even though you send the same data. Then we take the encrypted packet, we encode it using base 32, which is explained by the fact that DNS hostnames are not allowed to contain any kind of characters. But base 32 is a pretty decent set of characters for this purpose. And then you have to add dots every 63 characters, because this is in the domain name standard, I don't know why. And then we add the wildcard hostname domain to the end of it. And we decided to stick to our own domains because, well, we don't really want to send a lot of crazy stuff to our clients' networks. Someone might get pissed for that. There's a 254-byte host name limit as specified in DNS. This is why we have a data limit of about 90 bytes. Sort of depends on how long your wildcard domain is. So, from the client side, you can actually do pretty funny stuff, because instead of doing HTTP requests, now we're just listening to DNS traffic. So you could actually tell the browser to do a DNS prefetch by creating a link element like this. That means telling the browser to do a DNS lookup for this domain name, but don't send it any data. So this is great, because then you can actually extract the data from the browser without having to use HTTP. However, it won't work if the browser is set to send the traffic through a proxy. So for this reason, we have a fallback to XML HTTP requests. And it's actually surprisingly reliable, even though like UDP is sort of a lossy protocol and drops packets from time to time. DNS is really persistent. I mean, like if you don't get a response back, the DNS server will keep on trying. So the DNS packets will actually eventually, most oftenly at least, go through to the server or to the general direction. Some name servers are a bit whiny, and if they don't get a response for a particular domain, they will stop querying that authoritative name server. But in the end, like DNS packets tend to find their way out of networks, even though you sit on some really isolated segment. Another really interesting aspect of this is the fact that you don't actually need to open your firewall from the machine that's doing the sniffing, because libpcap is actually sniffing before the firewall. So you can actually have like a completely firewalled machine and still pick up this traffic. However, it's a bit hard to determine whether or not the sending of a particular message was successful or not, because there's no channel back to the client. Also, there are, of course, a few security questions, whether it's secure or not. But for now, we'll leave them up as an exercise to the listener. And please do come up to us and have a chat about this later. We have a few ideas. on potential issues. That being said, I'm going to try to see if this actually works. So here's a debug output of the sniffer. And here is my mail client. And I really hope that no one will send me a sensitive email right now, because that would be a bit embarrassing. Of course, like our motto is fuck it, do it live. So we have this deployed on our website right now, even though it's not really linked to, because it's not super duper reliable, but hey, let's try it. So, organization SecT, some name, Kalle, Spectral maybe. Did I send it? I don't know. Hello, world, SecT, maybe. And can have a look at the browser. I mistakenly sent one because I hit enter. Anyway, pushed it, and now we see it actually attempts to do XML HTTP requests. Over this side, you can see the debug is actually receiving host names from wire and reassembled the packet and sent me the mail. Yay! So this is the form that was posted and exploded into DNS, now reassembled and sent in the mail. So it actually worked. I'm pretty surprised, almost. Like, are there any practical uses for this, apart from, of course, this being a funny way of sending form mail? Actually, when you start thinking about it, it might be suitable for whistleblowing. I mean, like, if you really don't want to reveal which client is sending the data, having the client exploding it down to completely unrelated DNS domains makes it really hard to track without having the client installing Tor or something. And, well, sure, there might be other use cases as well. Like, think about it. You can just download the code at Christer's GitHub repo. And Christer is really the guy that's been making all the heavy lifting here. And the code actually looks really good, but it's in a constant flux. So, like, download it before it breaks. But that's about all for me. So, thank you.